So this is something you've learned in grade 11 a little bit, and it's called the reciprocal function. So 1 over f of x, okay, and again f of x is y, so your coordinate is going to become x comma 1 over y. Okay, so the coordinate 5, negative 8 is going to become 5 comma negative 1/8. Negative 6 comma, what happens when you reciprocate 1/2? Becomes 2. Okay, 1 divided by 1/2, right? You're just flipping stuff. Okay, 3 comma, what happens when you reciprocate the value 1? You get 1. Hey, that would be called invariant, right? What else is invariant? There's another value that's invariant. Negative 1 as well. Okay, 5 comma, so the reciprocal of 0 looks like this, 1 over 0. What do you guys know about that number? Undefined. Okay, so how would I graph undefined number? An asymptote. Do you remember that word from grade 11? Asymptote. That's an undefined value. Okay, here we go. So I always break it down into 4 steps. So I always do the height of 0, because the height of 0 is important. It creates undefined, which creates an asymptote. So that's where I always start. The height of 1 and negative 1, that's where I go next, because it's invariant. Right? Flipping 1, flipping negative 1. That doesn't change those numbers, so that would be invariant. If your number is far away from 0, for example, if you have a height of 100, the height of 100 is really far away, it will now go to close to 0, right? 1 over 100. So big to small, or small to big, or whatever, right? So now if I'm close to 0, you know, something fractiony, now so if you have a big height, you become small. Small heights become big. Okay? And never change positives and negatives. That's not what this is. Sometimes I get people who do that. That's not what this is. What does an invariant point mean? So from original to the transformed graph, it doesn't change. A point that's on the original, and then it goes to the transformed graph, it's not even going to move. Okay, here we go. Graph 1. So I always do, hey, where's my height 0? 6 comma 0. So it becomes 6 comma asymptote. Negative 3 comma 0 becomes asymptote. You might even get a simple question on your exam that says, if you were to graph the reciprocal of this, where are the asymptotes, or what are the asymptotes? You would just have to answer x equals 6, x equals -3. If that was just your question, I've seen that before. Just what are the asymptotes? X equals 6. Okay, now I go to step 2. What's invariant? Where do you see a height of 1? Right here. Where do you see a height of -1? Well, you don't. So there are 2 invariant values. Okay, now if you look at where I've highlighted here, what do you know about the heights? They are getting closer and closer and closer to 0. So what should you do instead? Move those points farther, farther, farther away. Or if you want to think about it, smaller, 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 so you're turning them bigger, bigger, bigger. Can we also do that to this little section between -2 and -3? We got really small numbers, or close to 0, so can you move them away? And this highest coordinate, which is 0, 4, I should move it to 0, 1/4. And there you go. What if I asked you the domain of my new graph? What do you know? What's the most left you ever travel? -3. Okay, we have to talk about our inclusivity brackets. Should I include that or don't include that? Don't include that. You don't touch it. You get close to it. You don't touch it, right? But never, you will never, asymptotes, you never, never, never touch, okay? All right, last one for the day and then you're up. All right, so height of 0. Height of 0, that happens twice. So again, if I just was asked a question about where are the asymptotes, x equals 2, x equals -4. Invariance, how many invariant points do I have? 3. 1 there, 2 there, 3 there. Okay, this little V shape, very similar pattern to this V shape, right? So there's a section that I'm going to take close to 0 values. Instead, I'm going to move away. Close to 0 values, I'm going to move away. And I think I gave you a hint here. This point, is there maybe a hint on my paper? I think I had this question and then I tried to erase that, but it didn't really erase it. I know, I just copied this graph. And that was my hint to you. Okay, now we're going to go to this next section. So, do you see where my pen would be right now? I'm going to call these heights close to 0. So can you move them away? And the final step, what's happening to that last part? It's moving away, away, away from 0. So what it's going to do is move closer and closer and closer to 0. And I'm going to keep doing that, and keep doing that, and keep doing that, which means something else has to be added now. You also are creating an asymptote behavior horizontally. Okay? It did not happen on the first graph because there was nothing on this first graph that continued to be going away. So if I had drawn a final point there, you would have a final point, no asymptote. But because of the arrow, it's only because of the arrow, that's what does it. That's the only reason. Okay, let's talk about domain. This one's a little bit trickier because there's a bunch of stuff going on. Okay, start me on the left-hand side. What's the leftist I go? -4? Okay, so get me at -4 round bracket. Where can I go to? I can go to 2. Can you hit 2? No, so you have to take a break. Okay, so can you step over top of 2 now? Or we're gonna continue. Can we continue right away after 2? Right after 2? And then what can we do after 2? Infinity. Okay? I am going to show you a different way to write this. You could say you go from -4 to infinity, but skip over. So you could say x is all the real numbers from -4 to infinity, except you can't hit the 2 in that zone. Okay? So as long as you've indicated some kind of domain showing me like those x values can't be on them, okay? Can't hit -4, you can't hit 2. You got to make sure, like if you're on a road, you got to, like a pothole, you got to jump over it or something, okay?